Ready? Everybody please pay attention. That's question 2. Is that 2? No. 3. The function is y equals negative, yes?
X minus 4.
Divided by?
X squared plus 3x.
Okay. So, the intercept, the first is what? The asymptote, right?
Yeah.
Find the equation of asymptote. Okay. So we have y equals 0, or horizontal asymptote is y equals 0. Okay? So vertical asymptote are, because there are 2 of them, x equals 0, x equals negative 3. Yes?
Yes.
And what else is there? Find the intercept. Okay? When x equals 0, y is undefined. So which means no y-intercept. Okay? Infinity mean does not exist. Okay? When y equals 0, x equals 4. No, negative 4. So that is the x-intercept. What else do we have? Sign diagram. So I'll find sign diagram. So we have, what are the important points here? The asymptote are 0 and negative 3. And what again? Negative 4. So I have negative 4, negative 3, 0. That's what we have. So which one is a broken line? There are 2 broken lines, right?
Yeah.
The 0 and negative 3 are the broken lines. And this is a thick line. Okay? So that's an intercept. So after this, we substitute any random value. So I just pick a positive number. So it's above 0. So I pick 5. This is negative 9. This is positive something. So this must be negative. Then alternating, we have that. So then we discuss the behavior. Okay? The behavior of the graph as it moves close to the asymptote. And what are the asymptotes? We are talking about these 2. Okay? Now, as x tends to negative 3 from above, as x tends to negative 3 from below, we also look at as x tends to 0 from above, as x tends to 0 from below, and finally, we will look at as x tends to infinity, positive infinity, and as x tends to negative infinity. So these are the 6. Okay? Now when I'm talking about as x tends to negative 3 from above, negative 3 coming from here, you don't consider this, you consider the closest one, right? And that's positive. So which means y tends to what? Y approaches positive infinity. Okay? Then from below, what happens? Which is here. Y approaches what? Negative infinity. Okay? Then for 0, come again. For 0 from above, what happens? Y approaches negative infinity. Yes? And for 0 from below, so from this direction to 0, that's positive, y approaches positive infinity. Okay? And finally, when x approaches infinity, positive infinity means this part, right? What happens here? So y approaches 0, definitely, because from the equation we could see that. Okay? When x becomes like this, approaches 0. But 0 on the what? On the negative side, right? On the 0 on the negative side. So that's from below. Do you understand? Is it? No, sorry. When this becomes big, yeah, we're right. When this becomes big, this is negative infinity, positive infinity. Wait. Which is can also be seen from here anyway. Hello?
Yeah.
Do I need to repeat that? When x approaches infinity, x becomes large. You can see this is negative. Since all this is negative, so why must be approaching 0 from below? Because everything is negative, everything is under. So the y is definitely coming from under. Why is not coming from the top?
Also, it depends on the side.
Definitely, yes. So because this is positive now it's coming here. When it's coming here, what happens? Y is becoming so big. So y is actually at the top of the graph. So it means it must be coming down and moving close to 0, sort of. So y is positive. So y approaches 0 from above. So this is what led to this. Now, something was confusing at first. Let's pretend we are drawing it from the beginning. So this is my xy coordinates. Please listen. This part was confusing to us at first, but I think we now realize it's because of the complicated nature of the curve. So quickly, the first thing I would do, there's no y-intercept, but the x-intercept is -4. So I put it right here, -4. Then I have a -3, then I have a 0, and that's all. Now, for 0 and -3, this is the vertical asymptote, and also another vertical asymptote. Yes? Then for the horizontal, the vertical x-intercept is this, so it's going to cross through here. Now, picking the first one, when x approaches -3 from here, so from here, this guy is positive. When x goes here, the curve goes up. So we just pretend, oh, the curve is, when this guy is moving like this is going up. Okay, we're going to draw it better later. When x is coming from here, so we're talking about between these two because it crosses here, right? So we're talking about what happened from here to here. Y goes down. So when this dude is coming like this is coming down. You see, I am moving on the green line this way, the curve is going down. Yes? So we can leave it at that, and it's going down, we know it will never touch. When x approaches 0 from above, so when this comes here, okay, y goes down. So as I'm moving here, my friend is deviating. Yes? Then when x approaches 0 from below, this way. So I'm coming here, what happens to the graph? It's going up, which means, oh, rather than cutting and coming down, it's going up means it saw something is afraid of and decided to just turn around. Maybe it's afraid of caring, who knows? Okay, something like that. Okay, so there's nothing here, so we have talked about this, and this. Now the last two. When x becomes so big, oh, I thought we've done that. When x becomes so big, y goes down. And when x becomes so big on this side, y goes up. So which means it's going to cross, definitely. So what we thought at first is maybe it's going to go this way. That was what we thought. Okay, but that's not the case because it's going to be contradictory to something. Wait, which one have I not used here? Have I used this? 0 from below. 0 from below, positive infinity, yes. 0 from above, going down, okay. Then infinity, when y tends to positive infinity, it still goes down. Yeah. So you see, look at this. When y tends to positive infinity, when x tends to positive infinity, y tends to 0 from below. So it's just a supporting statement. Y comes from below and is approaching 0. Okay? So this is the part that was confusing. How do we see that here?
It goes up.
Well, on this side, right? So y approaches 0 from above. So we thought it's coming from above this way. Okay? That was the whole thing. Actually, it's actually coming from, wherever here, and it's approaching 0. Something like that, according to what we later found out. So this is a bit complicated. That's a very, very strange graph. Let's hope that others are not that strange.
When the example you give us in China, If at the start, the class starts,
Yeah, the
do
first question was
example.
also like this.
Yeah, it wasn't like this.
It was.
It was?
Yeah, the one I was asking.
The first one, the second one.
Yeah.
The one we did on the board?
Yeah.
It's like this?
It was one like.
Question A was like this. That's what I was like.
Wait. The one we did today?
Yes.
Yeah.
The example?
Yeah.
Yes, wait, where is it?
Where is it?
Wait, which one is it? Yeah, this one. So here. It's the opposite.
The one I show on the board from the textbook?
Yeah,
Oh.
it's this one.
Wait, no, the one you showed is the third one. That one is not.
A is also like this. But it's like opposite.
No, what I mean is this. This investigation.
No,
that's
this
what I-
one. Like the one
the one-
at the beginning of the class where you
when you
asked
go
us to do like
down,
A,
that's
C,
the-
E or something.
Oh, the investigations.
The A is like that. That's why.
Oh, I see. Okay, so basically, I think when we do a series of sketches, you are likely to see some ambiguity and some things, and you can maybe understand some patterns. All right. So I think practice will really help us. But we have 10 minutes, and I really want us to do something before we go. So please, everyone, please, can you skip that? Everyone, I need you to look at this. So we're going to do this together, okay? We're doing this together. Please pay attention closely. Consider this function. Now, what's the difference between this function and the previous one?
This is improper.
Oh, yeah. Say that again?
Improper.
Improper. So for improper rational function, you are not going to have vertical or horizontal asymptote. You might have vertical asymptote. But in addition, you are not dealing with horizontal. You are dealing with a slant or oblique asymptote. That's what I wrote on the board. Why is it slant? The idea is this. I don't want us to waste too much time because I don't want to go into this next time. You just have to take your time and practice the worksheet and come back with any question you might have. Graph to also learn some things on your own. Consider this function. State the equation of the vertical asymptote. That's easy. X equals 3. Okay? I need you to pay attention, sir. Show that this is equal to this. This is partial fraction. Remember, we've discussed this before. Okay? Now, as x tends to infinity, this becomes 0. So your so-called horizontal asymptote is now a linear equation. And that's why it's now a slant. Does this make sense? Because normally, if you have y equals 2x plus 1 divided by, say, x plus 1, we know it's going to be 2 plus something divided by x plus 1. So that as x approaches infinity and this becomes 0, the only thing y approaches is what? 2. So that's why we say y is equal to 2 is that horizontal asymptote. But this time around, you're having y equals some ax plus b before your fraction. So which means when this vanishes, what happens? Y is left with a linear expression, which could either be this case or in this way. Then it's no longer horizontal. It's now a slant or oblique asymptote. And that you only experience when you have a rational function with quadratic over linear, instead of linear over quadratic. Does that make sense? Okay? So, let's see. So we're not going to waste time. Let's take one of them. Use technology to sketch this. So let's sketch the first one. X squared minus x squared minus x minus 5 divided by x minus 3. Check this out. I'm going to take that off. Can you see? Now, when that was broken into 2, did you see that? That's x plus 2. This x plus 2 is the equation of the slant asymptote. Let's put that and see. So y equals x plus 2. Uh-oh, no. No? Is that? Oh, okay. Can you see this? It just pretends to touch. It doesn't actually. If you enlarge it, you see. Can you see that? It just pretends to touch. It doesn't touch it really. Okay? Now let's see. Come on, did I go that far? So let's see the second question. 6x squared minus 3x. Get out. Minus x. 6x squared plus x plus 3. Okay. Didn't get enough sleep. Oh, minus 3. Okay, I didn't get enough sleep. Then 2x plus 1. Now, when that was broken into 2, do you see 3x minus 1? Let's put that equation. 3x minus 1. Did you see?
Whoa.
Usually, there are just two shapes to see. Is either the shape of this or the shape of this one. There are just two shapes. Okay? Is either you have this type or you have this type. What do I mean by this type? Something like this. Something like this. So you have with something passing in between, or this one. Let's check the difference. Can you see? This one. So where it's coming from, wherever it comes back, unlike this one, okay, you can have something like that. So there's a reason for having this. And of course, this could flip. So this could also come this way if this line has a negative gradient. And if this line also has a negative gradient, this comes this way. So there's a question we'll discuss tomorrow. What led to this shape? How do we know this is the shape to look out for, or this is the shape to look out for? Okay, that's a question for tomorrow. So maybe what I'll do is, I've shown you this. We'll work on this tomorrow. I won't give you the paper for this. You still practice more on this type and observe different difficult shapes. But please, ensure that you sketch, answer the question in the right order first, before you check what the sketch looks like using your graphic display calculator or your Desmos app. Please do not do that at the beginning, okay? It's only when you got stuck, you have exhausted all possibilities, and you are wondering what kind of shape will I get, something is not right, and you want to check, then you can look at what, otherwise, you know, you run into trouble. So please take note of that. Looks like I'm releasing you early. Usually I don't like releasing you fast. I like to punish you. By keeping you here. It's okay, thank you. Do I have any worksheets from last class? Any worksheets from previous? No? Okay, so bring it as soon as you're ready. Is that my worksheet, sir? Ma'am? Is that worksheet to be submitted? No? Okay.